when cells are connected in series, let us consider here n number of cells which are connected in series across an external resistor like this. This you take it as EMF E for each cell. Internal resistance is R for each cell. The order in which we have connected them, just look at that one, positive, negative order we are taking up. Now this is external resistance and this is the direction of current that is flowing across the circuit as such. Now in this regard, what would be the effective EMF? We can understand directly as NE. That means how many cells we are taking up here? N cells. And what would now be the effective internal resistance? That will again be NR. What would be the effective total resistance of the circuit? R plus NR. Now we just want from these two, what is the current passing through the circuit? You can directly understand NE by R plus NR. That is the formula one should remember. But the same concept, when few cells are reversely connected, how to write this formula? You can understand this way. There are again n cells. Out of them, m cells are reversely connected. Out of n cells, m cells are reversely connected. Then you can all understand straight away this way. The cells are connected in this order. Few of them are connected reversely this way. This is as usual the external resistance R. Positive, negative, positive, negative, positive, negative. Negative, positive, positive, negative. Now here positive, negative. You can take one more cell here, negative, positive like this. Then you can understand that each EMF now becomes E and internal resistance given as R. But what is the convention we go for? The cell which is regularly connected, if I take its EMF as positive, the one which is reversely connected, I should consider its EMF with a negative sign. So what do you find here? For every one cell connected reversely, totally two cells they get cancelled in terms of their EMF. The cell which is connected reversely cancels the EMF of another cell which is connected in a regular way. For example, if I take this cell which is reversely connected, that cancels one more EMF of one more cell. So if one cell is reversed, totally EMF of two cells in the entire circuit, they get cancelled. Now even here also this is reversely connected, that cancels even the neighboring one. So what you can understand here is, when m cells are reversely connected, then 2m cells get cancelled in terms of their EMF. That is the point. So what now would be the effective EMF of the system? It is n minus 2m into E. What would now be the effective internal resistance? that will remain the same, NR only. What would be the effective resistance of the system as a whole? R plus NR. Then what would be the current across the external resistance? Suppose if I ask you, you can say that N minus 2M into E by R plus NR. So this way we can even calculate what is the effective current across the system when few cells are reversely connected in this series sequence. In the same manner, when cells are connected in parallel, what would be the current across the resistance connected in the circuit? So cells in parallel, we now have few cells connected like this, all in parallel, and an external resistance is connected across this one like this. This is R. Each cell has an EMF E and internal resistance R. Positives are all connected to one end and negative side terminals are connected to the other end. This is what is called parallel combination. Now in such case, we all know all these cells which are connected in parallel, their effective EMF is going to be equal to the EMF of an individual cell out of them. So we can now write here the effective EMF now becomes E, whereas effective internal resistance, that now becomes R by N. What for we people are taking up N here, you can understand. N cells are, I am connecting them in parallel. Now you can say effective resistance becomes R plus R by N. Thereby the current becomes E by R plus R by N as such. So this is the amount of current that is passing through this resistance. One should remember this. But in the same manner, suppose there are two cells which are connected in parallel this way. Its EMF is E1 and internal resistance is R1. Its EMF is E2 and internal resistance is R2. If this is the case, what would be the effective EMF of the system? That also should be remembered. If I consider the current across this one as I1 and here as I2, both of course mix up here to give the total current as I. Once again I1 of course enters this way, I2 enters this way, I once again comes back like this. So in such cases we can write that I is equal to I1 plus I2. Applying Ohm's law, I is E by R. So we can write the same thing this way, E effective by R effective, that is equal to E1 by R1 plus E2 by R2. In other words, you can write that one E1 R2 plus E2 R1 by R1 R2. Therefore, what will be the effective EMF is the question here. You now can write E1 R2 plus E2 R1 by R1 R2 into what is effective internal resistance here? R1 R2 by R1 plus R2. Now R1 R2 getting cancelled, you are now left with the effective EMF as E1 R2 plus E2 R1 by R1 plus R2. This kind of a concept also that is important for you. So whenever two cells are connected this way, what would be the effective EMF of the entire system? You can calculate using this formula. Suppose an external resistance is connected. What would be the current across that one, they may ask you. That time effective resistance you have to calculate. This becomes effective EMF, and therefrom you can estimate what is going to be the current across the external resistor R. So these areas, as far as internal resistance of a cell that's concerned, one has to remember.